Today, Mars is known as a cold, dry desert, yet its landscape tells a very different story about its distant past. Networks of channels, water-altered minerals, and other geological features show that the planet once had abundant liquid water and a far more active environment. Scientists have spent decades trying to understand how that wetter world transformed into the barren planet we see now. Although several mechanisms have been identified that could account for part of the water loss, a large portion of it has remained unexplained. The first clear evidence that an unusual, intense, but localized dust storm was able to carry water vapor into the upper atmosphere during the Northern Hemisphere summer. Previously, scientists believed this season played only a minor role in water loss. The findings reveal the impact of this type of storm on the planet's climate evolution and open a new path for understanding how Mars lost much of its water over time. For years, researchers have understood that dust storms can influence how water escapes from Mars. However, most attention has centered on massive storms that engulf the entire planet. The new study shifts that focus by showing that smaller regional storms can also propel significant amounts of water to very high altitudes, where it can more easily drift off into space. In addition, earlier work emphasized the Southern Hemisphere summer, which is generally considered the main season for atmospheric water loss because of its warmer and more energetic conditions. The team observed an unusual surge of water vapor in the middle layers of the Martian atmosphere during the Northern Hemisphere summer of Martian Year 37, 2022-2023 on Earth. This spike was linked to an anomalous dust storm. At those heights, water concentrations were up to 10 times higher than typical levels. Such an increase had not been recorded in earlier Martian years and was not anticipated by existing climate models. Soon after this spike in water vapor, scientists detected a marked rise in hydrogen at the exobase, the region where the atmosphere merges with space. Hydrogen levels reached 2.5 times those measured during the same season in previous years. Tracking hydrogen is crucial because when water molecules break apart in the atmosphere, hydrogen can escape into space. Measuring how much hydrogen is lost helps researchers estimate how much water the planet has permanently shed.